Alright guys, welcome to 6-6. This is going to be the last section that I post for quadratics. I know we're in the last 2 weeks here left at school, so what I wanted to do is just wrap up any knowledge that you need to know basically for grade 11 math, which is on quadratic representations, and I guess tying in what you did in the quadratic factoring unit and seeing how it applies with all the terminology we've learned so far. Okay, I want to give you guys nice congratulations on everything that you've been doing, all the assignments that I've been marking so far, especially some of the extra credit stuff have looking great, so keep going with that. What I want to do also after this section, we have one more unit technically, however I just want to do like one lesson on it, which is basically on surface area and volume, so I knew it was a pretty straightforward unit, so I left it to the very end. So you should also keep your lookouts for that. And again, I'm just trying to prepare you for grade 11 math. As you know, math is a very unique subject, different from the other subjects where you do need knowledge from the previous year. And I know because of the pandemic, that has been definitely a difficult thing to sort of work through academically, but I'm trying as best as I can for you guys to still get in the lessons and the knowledge that you'll need so that you have the skills for grade 11. Okay, so today I'm actually going to tie in everything that we've been doing so far in the quadratic unit section. Whether you are taking 11 mix or 11 college math next year, you will need to know this stuff. Because some of you have been returning your textbooks, you probably don't have any textbooks at home to refer to. So again, just use the notes as a reference point. Ask me for questions. I've met with a couple of students online to help clarify any questions, so continue to ask for help. I'm more than happy to do that for you. And yeah, we'll get started here. Okay, so your learning goal is to solve problems by interpreting the significance of the key features of graphs obtained by collecting experimental data involving quadratic relations. So looking at the different features of a quadratic function and just tying everything together is the purpose of today's lesson. Okay, so overall, we know if it's quadratic for three main reasons. Okay, so these three reasons are the big three key points that we've been talking about all unit. Okay, so in equation form, the highest exponent of x is x squared. Okay, so you'll see here you have two x's, but you're always looking for your highest exponent. Okay, in the example of this, y equals x cubed plus x squared, this was an example borrowed from the last lesson, this would not be quadratic because of the x cubed. Okay, so although there is an x squared, as part of the question, it has to be the highest exponent. Okay, so that's something that's very unique and must happen. Okay, so visually it must look like a U-shaped graph. So again, we have our U-shaped graphs, and remember there's two possibilities. It can open up or it can open down. Remember, if it opens up, that is a minimum that it has, and if it opens down, it has a maximum value. Your last reason to know if it's quadratic is if in a table of values the second differences are constant. Okay, so meaning they're the same value. So remember, a table of values looks something like this. Okay, so again, calculating your first differences, you would do 1 take away 0, which would be 1, 4 take away 1, which would be 3. Maybe I'll add one more just to ensure that we got everything in there. Okay, and then we would do 9 take away 4, which would be 5. You would see at that point your first differences are not the same, which would require you to complete your second differences. And once you realize that your second differences are constant, then we know it is quadratic. Okay, so those are some talking points that we discussed in last week's lessons. Now, what I wanted to introduce to you today is more so focusing on example or reason number 1, so in equation form. So in equation form, there's actually a couple of different ways that you can consider the look of quadratics. So looking for y equals x squared, what does that look like in equation form? Well, there's basically three looks that we can consider, and these three looks are what I'm highlighting in yellow currently. Okay, so y equals ax squared plus bx plus c. You can visibly see that x squared. Y equals ax minus r, x minus s. So you might look at that and say, well, miss, there's no x squared that's there. However, if we apply the FOIL method that we learned in our earlier unit, that definitely would FOIL or expand to an x squared. Okay, and then your third look is y equals ax minus h squared plus k. Now, each of these forms do tell us that it is quadratic just by looking at its equation. And uniquely, each form actually tells us something about the parabola. Okay, we're going to go into the specifics in this lesson so we can actually see what those key characteristics can be given from the equations. All right, so once again, we're just focusing on that x squared piece. Now, going back to what we did in linear relations, so you might recall when we looked at anything linear, we followed the format of y equals mx plus b. Now, if I asked you to find your y-intercept, which is something that we did do back in February, sometimes we're looking for a y-intercept, what letter in y equals mx plus b would tell you your y-intercept? Now, we always said m always told us our slope, so rise over run. The letter b tells us our y-intercept. Okay, so as an example, if I did the equation, or if I had the equation y equals 2x plus 1, we would say the y-intercept is at plus 1. We call that our constant. Your constant is the term that has no letter associated. It is just a number that's on its own. Okay, so plus 1 would be your y-intercept, and as a value on a Cartesian plane, right, that would be right there at 0, 1. Now, let's tie that into what we're going to do here in quadratics. Okay, so for our bullet point that's red here, for a quadratic relation in standard form, so standard form is ax squared plus bx plus c, the y-intercept is c. So in this case, it's still your constant. And we know it's the y-intercept because when you sub in x equals 0 into the equation, your c value actually tells you what your y-intercept is. Okay, so for instance here, if we look at 1a, if we sub in x for 0, zero squared is 0, 5 times 0 is 0, I'm just left with 4. So this means your y-intercept is 4. You don't even need to do all that work. You can just look at the term that's by itself with no variable next to it. So in B, that would be 15, and in C, that would be negative 16. These are all the y-intercepts for those 3 quadratic equations. Okay, so pretty straightforward stuff for that at least, right? So it's similar to how we distinguish y-intercept for linear relations. Look at the last term or the term that has no variable next to it. Okay, the reason why I don't always say the last term is because if I wrote the equation like this, right, it's the same as part C, I just switched the last 2 terms. So I put negative 16 and then plus 6x. Your y-intercept would still be negative 16 because that is the term with no variable beside it. That is your constant. Okay, so hopefully that makes sense. We did this in Unit 7 where we actually were given quadratic expressions. So I'll take the y equals x squared minus 2x minus 3. Now you're probably doing all that work and you're wondering what was the purpose, why did we need to learn how to factor? I'm going to draw that connection today. Okay, so the purpose of factoring something like this, so this is your trinomial. Remember, I know it's a trinomial because there's 1, 2, 3 terms. You would recognize that it's a trinomial and it's actually a simple trinomial. And it's a simple trinomial because the coefficient of x squared is 1. So what you would do at this point, just to draw some examples of what you did in your last unit, remember we would think, okay, what multiplies to -3 and adds to -2? So what two numbers give you a product of -3, one multiplied, and also a sum of -2? So if you want to pause the video, try and think about it. Okay, your answer should be -3 and 1. So remember how I would write this out. You would write this as x minus 3, x plus 1, where these answers go inside the binomials. Okay. Now, if you look at the graph here to the right, it already actually has your graph. And you'll see we have our vertex, we have our y-intercept, and we also have our x-intercepts. Now I'm going to do those in a different color just because I'm going to draw a connection to why we factored and what it shows on a graph. So if you take a look at what I factored here, we would have stopped here and we would have said, okay, we're done. We've just factored that. Now the purpose of factoring finds x-intercepts. Okay, so factoring finds x-intercepts. I want you to think about where these two x-intercepts are, okay, that I've highlighted in green. Okay, for it to be an x-intercept, remember, it's always going to be the value that it crosses the x-axis and then 0. That's always the format. And if you look at that as a coordinate, that means that's x, comma, y. Y is always going to be 0. So if y is always going to be 0, I can actually take this y here and I can replace it with 0. Okay. Now what I'm going to do then from each extension is I'm going to take 0 and I'm going to set it equal to each binomial. And I'm going to say solve for x. Okay, so how do we solve for x? Well, that's like our algebraic steps that we did in chapter 3. So a number minus 3 is 0. Well, quite simply, I could just take that -3, bring it to the left side. That then will equal 3 is equal to x. I could do the same thing here. -1 is equal to x. Now look at this. These are our x-intercepts. They're the same. Okay, so factoring finds x-intercepts. How we did that before, you would be looking at a graph. And you might think about, well, what if you don't have time to graph a graph? What if you don't have time to put into Desmos? Or if you don't have any graph paper? You can find your x-intercepts very easily by factoring. Okay? All right. So for all of these are actually already set up for you. So what I'm going to do is I'm going to sub in 0 in for y, and then solve for your x-intercept. So this will be x minus 2 is equal to 0, and then 0 equals x minus 6. Okay, now you'll notice all we're really doing, for ones that look like this at least, is we're just swinging over the term to the other side, and it just becomes its opposite sign. Okay, so even for here, this could mean that x is equal to just -3, x is equal to -7. Opposite signs. X is equal to 5, x is equal to -3. Okay, these are all of the x-intercepts for equations that take this form. We call this factored form. And in factored form, R and S, which are going to be all of the values that I'm highlighting now in yellow, and you can see how it changes. right? Those become your x-intercepts, okay, or zeros, or solutions, or roots. Remember, they have many, many names. All right. Okay, so that's another thing we're piecing together. What I have here is just a little visual of what we recalled in terms of some key characteristics. So axis of symmetry, we see that dotted orange line that I've been drawing in the last week, your x-intercept, your y-intercept, your vertex. The only thing that's missing, right? So remember, if the graph opens up, you have a minimum, right? And then if the graph opens down, we have a maximum. Now, I'll give you a hint as well for this. For your parabola, especially when you guys were graphing the parabolas in the table of values last week, anything that has a positive coefficient in front of x squared will open up. Anything that has a negative coefficient in front of x squared will open down. Okay, so that actually helps you when you're trying to figure out if it has a maximum or if it has a minimum if no visual is provided for you. Okay, so it's kind of like a little thing to look out for. Okay, all right. So I have 3 questions that I want to go over here with you. And again, the purpose is to see what questions next year will look like, because as you know, ideas bounce off of your previous lessons, and I want to just make sure you're prepared. Okay, so we have an equation here, y equals x squared plus 2x minus 15. So if you look back up to the very top, this is in standard form. Okay, it is the first way that you can interpret an x squared equation. Now, does the relation have a minimum or a maximum? Okay, so again, we're going to look at the value in front of x squared. If it is positive, it opens up. If it is negative, then it opens down. So in this case, the a value here is 1, and it's a positive 1. So this means that this parabola opens up, and it has a minimum value. Okay, so we could say it has a minimum. What is the y-intercept? So remember, you're looking at the constant term. So y-intercept is equal to negative 15. As a coordinate, that would be 0, negative 15. And then your zeros. Okay, so we have y equals x squared plus 2x minus 15. So for this one, we would see it is, again, simple trinomial factoring. So we have to apply, what multiplies to negative 15, what adds to positive 2, what are those numbers? Okay, so the numbers in this case would be 5 and 3. Now, which one should be negative because I have a negative product? Well, if it has to have a sum of 2, that means the smaller one should be negative. Okay, so I'm going to go y equals x plus 5, x minus 3. Now, because it's asking what are the zeros, we're actually going to take what we did above and we're going to switch the sign. So if that's x plus 5, my 0 will be at negative 5, or x-intercept. X-intercept at x equals negative 5, and if this is x minus 3 in the binomial, it'll be x equals 3. Okay? How do you feel so far? All right. We'll try another one. Okay, so once again, we want to see if it's a max or a min. We will look at a in this case. A is equal to a positive 2, so that's the value in front of x squared. This also opens up, meaning I have a minimum. So if I have a minimum right there, what is the y-intercept? So we're going to look at the c value. So that's 16 or 0, 16. Okay, and then we're going to find the zeros once again. Okay, so yes, it definitely is a trinomial. However, it's not simple, at least at this stage it isn't. You'll notice this has an x squared. So I'm going to take out the GCF. In this case, I'm going to take out the GCF of 2. So I'm going to divide every term by 2. Okay, so remember y equals, GCF goes at the front. When I divide each term by 2, it should simplify to what I have here in brackets. X squared minus 6x plus 8 with GCF at the front. So now I'm going to apply simple trinomial factoring steps. So it multiplies to 8 and adds to negative 6. I'm going to go with negative 4, negative 2. So I should have 2. And what I factor in the brackets, x minus 4, x minus 2. Okay. Now to find the zeros, we just have to apply it to what's in the binomial. That 2 that we pulled out, leave outside. Okay? This has nothing to do with the zeros. That's just the GCF that we pulled out. So the zeros actually are just at x equals 4 and then x equals positive 2. Okay? All right. So for your last one, number 5, I just wanted you to take a look at how it could apply to a real-world problem. Okay, so just in the wording, and then we would do the exact same steps that we've been doing the last 2 examples. So the curve formed by a rope bridge can be modeled by the equation y equals x squared minus 11x plus 10, where x is the horizontal distance in meters. So I would say horizontal distance. This was a graph in meters, and y is the height in meters. Now you can see there is a parabola right there. So what we're going to do is we're going to figure out, oops, that's a y. We're going to figure out how to factor it, how to find the zeros, and then the horizontal distance. Okay? So we have here y equals x squared minus 11x plus 10. So this is simple because the coefficient of x squared is 1. So it's what multiplies to positive 10 and adds to negative 11. Your numbers should then be negative 10, negative 1. So y equals x minus 10, x minus 1. That is the relation in factored form. To find the zeros, so remember I do my arrow work. So I have x is equal to 10 and x is equal to 1. So if we were to graph this as a parabola, okay, so it would look something like this. 1 could be there, 10 could be there. Okay, and this is my y-intercept. So y-intercept in this case is positive 10, 0, 10, which is right here. Okay, so this particular question is a little unique, so I just wanted to bring it up. What is the horizontal distance from one end of the bridge to the other? So really, from here to here, right? Because we know our x-intercepts. So between those two, I got to find, well, what's 10 meters minus 1 meter? 9 meters. Okay, so we can say the horizontal distance is 9 meters wide. Let me rewrite that. Okay. All right. Okay. So hopefully these questions made sense and that they were clear. I know it did build off of a couple of past concepts, so it's very possible if there are a couple lessons that you didn't understand, even in your Unit 7, ask questions so that it doesn't get overly complicated for you. Even if you just want to say, Miss, can you just rephrase or re-explain? No problem, I could do that for you. What I'm going to attach for you, and it's not for submission, but it's more so for you, okay? I'm going to attach for you a grade 11 what you need to know. Okay, so grade 11 what you need to know, and it's on quadratics. Okay, so in grade 11 there's a lot of focus that's still on quadratics. So this year does matter. Taking knowledge from grade 10 math is important. I'm going to post that document. Okay, I want you to try and do it and really just challenge yourself. It's more for you, just to kind of see where you're at, see what you understand. If you have any questions, please feel free to ask. And then in a couple of days, I'll also post the answer key so that you can compare your answers to what you were thinking when you were doing it on your own. Okay. I'm also later in the week going to talk about your surface area and volume. Okay, so again, it's just knowledge that you need to know for next year, and that's pretty much what we'll do the last 2 weeks. It'll be very calm and chill and easy as you guys wrap up and go into your summer. Okay, so keep up with the great work. If you have any questions, please do not hesitate to contact me, but that's all from me in 6-6. Okay, all right.